So I've kind of not made this video because, to be honest, I just thought the video would be boring. But a lot of people have actually written to me asking me, how do you clean the go once you've made it? So I thought I'd make a video. Now, if you followed the last video, large-scale production of graphene oxide, then you ended up with a beaker full of kind of an orange goop. And in that orange goop, you've got some unreacted graphite, your graphene oxide, some potassium, some magnesium, and some other bits and pieces floating around, and a hell of a lot of sulfuric acid. Now, the standard way of cleaning the graphene oxide, or the lab way of doing it, is to filter it and wash it. And to be honest, it's really jelly-like, and if you start trying to filter it, you won't get very much filtered before your filter pump gives up, and you have to start again, and it takes forever, and it's a real drag. And it also requires you to centrifuge it, and not a lot of people have a centrifuge available. So it's quite a difficult methodology to kind of approach when trying to clean some homemade go. So I've come up with this method of doing it, and the major thing that you're going to need to do this is patience, because it takes about a week, sometimes a bit longer, depending on how quickly the go dries. But it is really easy. So the first thing you need to get rid of is the sulfuric acid, because the whole what we're aiming for is dried, contaminated go. And the reason we want it dried and contaminated is that although the go is dispersible in water, it's not strictly soluble, and it takes quite a long time to disperse in water. You need a bath sonicator to really get it in there. But the salts that are in there and the metals that are in there will dissolve with the appropriate solvents really quickly and easily. So once you've got your go dried and in a powder, if you wash it with hydrochloric acid, that's a 10% hydrochloric acid solution incidentally, you just wash the powder over with that. Yes, you'll wash a little bit of the go away, but you'll wash all of the metal away, leaving you with a slightly acidic solution and some soluble salts in there. Then what you do is wash that with water, and all of the salts will be washed away too, and you're left with pretty much pure go. Actually, go with some unreacted graphite in there. So what you first need to do is dry the stuff. Now, because you've put quite a lot of acid in there, it won't dry particularly successfully. You'll dry it, but you'll get this layer of sulfuric acid, concentrated sulfuric acid, coming back out. And it leaves kind of like an oily layer on the thing. So the first stage is to get rid of the sulfuric acid. And that's what I'm doing here. What I've done is taken my orange gunk, which is here, and poured it into this container. Now, I made about 400, 500 millilitres of this stuff. So I made it, set it to one side for 2 days, and it separated out so that I could draw off 150 millilitres. So there are 350 millilitres of my go solution there. Drawing off that, letting it separate and drawing some off, is getting rid of some of the acid already, because the acid is there in solution. Now I took half of it and added it to this 2-litre jar. So there's 175 millilitres of the original solution in there, and then 2 litres of water. Now, if you think about it, at the beginning of the process, we bunged in there 100 millilitres of concentrated sulfuric acid at 96 to 98%. What we're trying to do here is get rid of that. We're using diffusion to do it. So if I've got half of mine in here, I've got 50 millilitres. And if I put it up to 2 litres, then what I've got here is quite a dilute solution of sulfuric acid. And most of the sulfuric acid is actually riding in this water here. So if I pour that water off, I'm also pouring off a hell of a lot of the sulfuric acid. Now, some of the sulfuric acid is going to be left in here, but it's going to be 1/40th of the original amount. So instead of being 96%, if we divide that by 40, then we're going to get 9.6, about 2% sulfuric acid. So we've got 2% sulfuric acid left in here instead of 96%. If we do that again, we get again 1/40th of it, so we get 0.2, divide that by 4, 0.05% sulfuric acid in there, which is really tiny. So you add 2 litres of water. Now this is ordinary tap water, it's not deionized water, and there's a reason it's ordinary tap water. Go actually only disperses in deionized water successfully. It's a colloid, so it's really sensitive to ion concentrations. So if you have too many salt ions in there, the go won't actually disperse in there. So there's an awful lot of sulfuric acid in here, there's all the calcium and fluoride ions from the tap water in here, so there's quite a lot of ions kicking around in here. And what we've done when we've done this, if we've prevented the GO from actually dispersing, it's coagulated in the bottom here. So what we have is coagulated GO, and then a mess of various salts and acids kicking around in this stuff. And what we do is just pour this stuff off. Do it one more time and pour it off, and you'll get a sludge at the bottom. That sludge at the bottom is the GO with most of the acid removed, and at that stage we can actually just sit this somewhere to dry it. Now you can't dry it at a particularly high temperature, because if you do that, the GO will actually be reduced back down to graphene, so you need to dry it quite slowly. What I do is just stick it on top of a radiator for a few days and come back to it when it's dry. So as I said, what I'm going to do is pour that stuff off. So I've poured off most of the water and I've poured it back into my beaker. There's about half a litre there. Again, it's mixed up. If I leave that now for a few hours, it's going to separate out again, and I'm going to get another layer of water on there, and you just pour that off again. When you pour it, obviously you disturb it, so it's going to mix itself up a bit. Pour off the water, but keep as much as you can as the GO, and then pour it into a smaller container like this, and when it's separated out again, pour it off. If you want to collect it off without pouring it, you can use a pipette to draw the stuff off with, or a syringe, and you can draw it off. And that should get down quite low actually. I'll get about 200 or 300 millilitres of that. Be about the same volume that I started with, but the important thing is most of the acid will have gone. So when I sit that on top of my radiator to dry, it will dry. It won't leave me that oily film of concentrated sulfuric acid on the top. Okay, so this is 2 days later. I've done the washing process twice, left it to settle out, and by the time it got small enough to put into the speaker, I put it into the speaker and let it settle out some more. And it's about the same volume. There's about 270 millilitres there. The difference between this one and the earlier one is pretty much all the sulfuric acid is gone, so this one will dry. Now, I could just pop that on top of a radiator and leave it to dry, but it'll take even longer like this, because obviously it's a function of surface area, so if you give it a nice big surface area, it'll dry quickly, or relatively quickly. You don't want to force dry this, because if you force dry it, then you'll ruin it. So all you do is pour it into some kind of container with a large surface area, and there you go. I use this little Pyrex dish, and I'll pop that underneath the radiator for a couple of days, and that will dry. And that's it. So here it is after 2 days of drying, and as you can see it's a kind of silvery brown orange colour. If you haven't got many of the salts out, you'll get lots of flecks of white in here, and sometimes they appear as little nodules. That's just because you haven't got much of the salt out, and it's at this stage they're actually trying to get the salts and metals out. So once you've got it to there, all you actually do is take some flat object, in my case it's a trimming knife blade, and scrape it out. Now it will come out in sheets. Doesn't matter if it doesn't, but as you peel it out, there you go, one sheet. Now that's actually a sheet of contaminated graphene oxide, so it's not very strong and it's not 100% dry at the moment, but that in fact is GO paper. It's just got lots of metals and salts in it. What we're going to do next is powder that. So first of all, peel it off. There you go. And when you've done that, we're going to grind it up into a powder. It's still just a little wet, and you can feel it's a little wet. It's got like a leathery feel to it. So if we try and powder that, it'll just clump together. But at this stage, you can grind it up, and peel it off and put it on a bit of paper and leave it until it goes really dry. Okay, so here we are 3 days later, and we have our dried GO. It still feels slightly leathery, but it's a kind of brownish colour, and because I put it into that big tray, quite pepperish. But anyway, there's the dried GO ready to make into a powder. Now I have this thing, which is a coffee grinder, and I keep this kicking around for doing exactly this sort of stuff. and you just pop your go into your coffee powder, into your coffee grinder. Put on the lid. Now it takes about 5 minutes of grinding to get it down to a fine powder, and it's pretty noisy, so I'm going to do that and then get back to you. So here it is after 5 minutes. Take the lid off and pour out your powder. And there it is, that's your Go powder. Now it still needs a bit of purification, and that's the next stage. Okay, so if I'm repeating myself, I apologise, but I've done this over a week, and to be honest, some of the earlier things that I said I've just forgotten. So if I'm repeating myself, like I say, I do apologise for it. Okay, so we've got this far. Now what we've done is we've taken our Go that we made from the previous video, and we're purifying it essentially. Now the Go that we made in the previous video, as I said, was full of acid and full of extra salts. So what we did was chuck a load of water in there. Working on the idea that the acid and salt would diffuse through the water and the Go separates out into a clear distinct layer, as you saw. Pour it off, do it again, pour it off, do it again, and eventually reduce the acid content to a manageable amount, about 0.01% or something if you do it 3 or 4 times, but very, very little. So you do it until more or less the pH is neutral, so 6.5, 7.5, that'll do you. And then you dry the thing. Now the reason we're doing it like this is because if you try to wash it as it comes out wet, it's a nightmare to do it. It clogs up the filter paper, it takes absolutely ages to do it, and it's just an absolute nightmare because your contact time is so long. This way, at least even though it's taken us a week, the actual contact time is very small. You fill it with water and leave it for a few hours, pour it off, fill it with water, leave it for a few hours. Then you set the thing to dry, and you leave it for about 2 or 3 days, essentially until it's dry. Then you grind it up into a powder, and this is what you get. Now, this stuff is full of impurities. There's still residual acids in there, obviously. There's a few residual salts, there's some unreacted graphite, and there's your Go product. And what we're going to do now is wash that. The reason we've done this is because although Go is dispersible in water, it's actually not very dispersible in water, and you need to use a sonicator to disperse it. If you pop it in water, some of it will disperse, certainly, and we have lost some product, certainly, and we're going to lose some more, 100%. But on the whole, you get a pretty clean product out of it, and you get quite a lot of product out of it. So once you've got it to this dry powder stage, the washing bit of it comes quite easily. Now, sitting in front of me is my little homemade filtration equipment. I have gone through this in a different video, but just to run through it again, this is a very cheap funnel that I bought, and I drilled out a disc of acrylic and glued it in there, putting in some silicone at the bottom, dropping the disc in, silicone at the top to make that filter funnel. And it makes a kind of very cheap Buckner funnel. Now these are about this size, it'd be about 50 quid or so. They're quite expensive. This particular one cost me £1. And that's a little bit of rubber handlebar tape to make the seal. This is obviously a wine bottle, and I drilled a hole in the wine bottle with a glass drill bit. And the secret with glass drill bits is put a little tape in there, masking tape on it, and drill through slowly. Let the bit feed itself through, don't push or you'll crack it. And just drill slowly, it'll drill a nice neat hole, and in there I put a spigot, and then I put some hot glue around that spigot. And that, obviously the wine bottle was free, the spigot was about 25 pence I think, so very cheap. This thing I actually had to buy. This is a filter pump, and it's 18mm mercury, 12 volt, 12 volt, 12 volt pump I got from eBay. It cost me about £10 or something like that. And it just plugs into the wall with its own little power brick, you turn it on and it'll pull about 18mm of mercury out of that. Fine, no problem at all. The other thing that we're going to need is this stuff. Now in here is a 10% solution of hydrochloric acid. I used a 35% solution and added 2/3 deionized water to get you a 10% solution more or less. And so that's a 10% solution of hydrochloric acid. Now I put it into this squeezy bottle. A squeezy bottle just means that it's easy for me to squeeze it onto my go as I go, so to speak. You'll notice, for the health and safety conscious amongst us, I'm wearing gloves. I'm wearing gloves because it's hydrochloric acid and because people moan at me if I don't wear gloves. Actually, it's only 10%, so normally I wouldn't bother. And to be honest, if you've got this far, you're pretty used to handling concentrated acids because you've already worked with 98% sulfuric, and if you're here doing this, you've come through it live. Well done. So 10% hydrochloric acid, I wouldn't worry about it particularly, but for all those people who want to wear a cotton wool suit when they're doing this stuff, then wear gloves, wear eye protection, and use some long sticks so you're a nice distance away. Otherwise, be sensible, wear gloves, and do it with a squeezy bottle. The squeezy bottle just makes it easier to manage, incidentally. Okay, so that's my setup. Now, for the filter paper, it's a coarse grade filter paper that I've got. You just pop it onto the disc there, making sure you've covered all of the holes, and just give it a little bit of a wet so that it sticks down. Pour your powder onto your filter paper. And all we're going to do now is turn that on and squeeze a bit of the acid on it and let it suck its way through. It's very noisy, incidentally, so I'll turn it on in a second, squeeze the acid on. It's half a litre. Pretty much by the time that half a litre's gone through, you're going to have washed away any of the residual metals that you've got in there. There won't be that many, so you're washing away pretty much with half a litre. Following that, we have a squeezy bottle full of deionised water, and you do exactly the same procedure. Squeeze the deionised water on while the filter pump is working. Obviously, when it gets too full, stop it and empty it. And when you've got a pH of about 7 from that, so you've done the acid, you're now doing the water, you squeeze the water on. When that stuff here is reaching pH 7, you're done. It takes about a litre and a half, something like that. And that washes out all of the residual salts and all the residual metals. So, let's give it a go. And you just keep on with that until your acid is gone. Okay, so after finishing off that washing in water, what you do is dry it again. And when you've dried it again, you stick it in a coffee grinder, and what you get is this brown powder. Now this brown powder is actually a mixture of graphene oxide and graphite. There's still a bit of graphite left in there. The way you get that out is you dissolve it, or rather disperse it in water with a sonication bath at something like 4 milligrams per milliliter. The go will disperse nice and cleanly. The graphite won't, it'll sink to the bottom. And you just pour off the top, and this time you keep the yellowish solution that you've poured off, and that's pretty much pure graphene oxide. If you want that as a powder, that stuff you've poured off, you'll have to dry again. Now, there's been some research saying that the reduction of graphene oxide to graphene starts to occur around 70 degrees. So if you leave it for a long time at 70 degrees, what you're going to get is graphene. But that graphene left for such a long time will start to stack up, and you'll actually just get graphite again. Now, which is why I warned you to dry it very, very slowly at a sort of 40 degrees or something. If you're putting it up there to about 70, or you try to dry it quickly, what you're going to get is back to your graphite, and that seems like a complete waste of time. So dry it slowly, don't be impatient with it. Remember, this whole process took about a week to do it. It's a little slow, but your contact time in it isn't so great. But don't be tempted to hurry up that drying process, because all you'll do is reduce your graphene back to graphite, and because it's non-soluble that way, it'll all stack back up again, and you'll just be left with a sheet of graphite, and that's not much use to you. So dry carefully. Anyway, once you've done that and repowdered it, what you get is about 6 grams or so. So we started with about 5 grams of graphite, and we end up with about 6 grams of graphene oxide, and that's no surprise. That's pretty good, actually, because there's been quite a high conversion rate there, and you've added a lot of oxygen in there. Now, without sending this off for some analysis, I don't actually know what the oxygen percentage is. I think it's reasonably low in this one, actually, which is Sometimes a good thing, sometimes a bad thing. It will disperse quite well in water. Actually, I can get this up to about 10 milligrams per milliliter concentration, so that's pretty good. And it also makes a very good material if you're using it for batteries or supercapacitors, so again, very good. The oxygen content doesn't really make it suitable for forming into thin films. It's a bit difficult to do that with it. So I'd have to up the oxygen content on it, and the way I would do that would just give it longer to react in the reaction stage. But there you go, that's how to wash and prepare the graphene oxide once you've finished the graphene oxide reaction. Like I say, I personally think it was a long-winded process and a long-winded video, now for which I apologise, but there's no other way to go around it really, to tell you step by step how to go around washing your Go product so that you end up with your nice brown powder that you can use. So I hope this was of use to you, and thank you very much for watching.